Okay, so I'm going to show you a quicker way that you can be dividing in situations that look like this. And this can also be useful for partial fractions as well. So let's get into it. So what we've got here is we've got on the top a fraction with an x squared as the order, so like the leading power, and then underneath we've got just the power of 1. So when this happens, I want you to kind of remember that sort of long division process, yeah? So I'm going to have a 3x squared there. I'm going to have an x plus 2 on the outer side. And the thing that's going to link them is going to be the term that makes x multiplied by something 3x squared. Okay, so actually, without sort of doing all of this stuff here, we could work out that a in this one here will be 3. Okay, however, for the b, it's a little bit more difficult. So we'd normally have to sort of do this process at least a little bit. But I'm going to show you a different technique you can do when you know the format of what you will get when you do division. Okay, so when we divide, what we're going to do is we're going to think that there's going to be some way to write this where there will always sort of be a term with an x, okay, and then we're going to decrease the power by 1. So we're going to say, and then there will be just a constant, and the reason for that is, you know, somewhere in here, imagine it's like 3x or 2x or something, it will be divided by x. So there'll be a constant hiding in there, but we can't work out what that is because, you know, we'd have to do lots of parts of our long division. However, if we carry on with this, the trick that we're going to do is we're going to use the fact that this is an identity symbol, which means this relationship is always true, to kind of avoid having to do this. So 3x squared plus 5x minus 1 over x plus 2. Well, if I change things on the right hand side so that they have the same denominator, how could I do that? Well, I could do that if I multiply the top and the bottom by x plus 2. And if I do that, I will get ax. The new bit I'll get will be x plus 2. And can you see that that would give me the same denominator there? Okay. Now I could do the same with the next bit. So again, with that new x plus 2 bit. And the c bit, well, the c bit is already done. Okay, so the idea of this is I assume that there will be a remainder left over still to divide. So that's where that sort of idea comes from. So what was this plus c, which is already over x plus 2? Well, now what I can do, because the denominators are the same everywhere, I can just sort of eliminate that, and I can use a skill like comparing coefficients. So what I'm going to do for this is I'm going to say, well, on the left-hand side of my equation, however many x squareds there are, for example, will be equal to however many x squareds there are on the right-hand side. So let me just show you that process a little bit more slowly. So on the left-hand side, whatever's there will be equal to the right-hand side for an identity. So on the left-hand side, there's how many x squared, how many x's, how many constant terms. Well, we're going to just work them out and we're going to compare them. So there are 3 x squareds on the left. How many are there on the right? Well, where will they come from? They can't come from here, for example. There's nothing here. So it will come from this number that I don't yet know, multiplied by x, multiplied by x. So in other words, there are 3 x squared on the left and there are a lots on the right. So a is equal to 3. And actually we sort of said that at the start, didn't we? We said that we could work that one out. Let's find out something like b though. So on the left, I'm looking over here, there are 5 of them. On the right, where do they come from? They come from a times x times 2. So there'll be 2ax. There'll be 2a lots. Now 2a, you already know what 2a is. You could just call that 6 straight away. Okay, so there'll be 6 from 3 times x times 2. Anywhere else the x's will come from. Well, they'll come from here as well, won't they? B times x. So there'll be b more. So what you can start to do here is you can start to say, well, a is 3. That didn't take too much work. B, what does b have to be? B has to be -1. And now, if we do this one more time, we should find out what c is as well. On the left-hand side, there's -1 for the constant term. Over here, ax, none of this is going to give me a constant. I've done it already. B times 2, that will work, won't it? So I could write 2b, but again, I already know that b is -1, so maybe I'll just write -2. Anywhere else, well, actually, it's just this term that's just sort of sat on its own as well. So plus c. So -1 is equal to -2 plus c. That means that if you add 2 to both sides, you'll get that c is equal to 1. Okay, so this comparing skill is very useful. I could say that this will be 3x minus 1 plus 1 over x plus 2. I can use this skill in situations like this where I know what the format of the answer will be. And like I said, that's not really that hard to work out. Let's just give you one more quick example. So if I said something like this to you, the answer is, well, it's the difference. So it'll be a, but the difference is x squared plus bx plus c plus some number we don't know yet divided by x plus 1. So it's the same sort of thing every time. And this is where you might want to use the skill. It's much quicker than division. We've got one more here. This one has fractions in it instead, but the skill still works. So let's speed it up a little bit this time. So the format is going to be px plus a number plus a remainder. And we could just jump straight in and say that if this has a 2x plus 3, there would be a 2x plus 3 here. There'll be a 2x plus 3 here. Okay. For this to be equivalent to this. So it says lightning skills. So let's show you that it is something that you can do very quickly. So this will be the left-hand side, and there's an identity with the right-hand side, which is, let's write it as px 2x plus 3 plus q 2x plus 3 plus r, and I could just drop the identity symbol now. I'm just going to put an equals in there instead. And I'd start comparing. Okay, so how many x squareds, how many x's, how many constant terms? There are 3, 2, and 5 here. Now, on the right-hand side, px 2x, that's where the x squareds are coming from. So there'll be 2p, lots of them. And that means that p is equal to 3 over 2. And that is correct. Where do the x's come from? Where the x's come from? They come from that multiplication, and they come from that multiplication. So you will get, I'm going to write it in terms of p, you will get 3p, and you will get 2q. Okay, and I could just sort of sub this value in there and so on and work out what q is. And let's do it one more time. So 5 on the left. On the right, where do the constant terms come from? They come from 3q. And they come from just r. Okay, sometimes sort of comparing coefficients can lead to solving simultaneous equations on your calculator. And if you do that, you will get p as 3 over 2, q as -5 over 4, and r in this case as 35 over 4. Writing these back in neatly, lots of ways you could do this, but it will be something like 3 over 2x minus 5 over 4 plus, if you want to see a different way that you write this fraction, you could do something like this. You can say 35 and you can put the 4 in the denominator, so something like this. So I hope you found that useful. The idea is that if we know the format of what it's going to look like, we can match it up by giving everything the same denominator, and we do our steps of comparing our coefficients. And it's a nice sort of shortcut that you can use. It comes up in a few places. You can have a go at this one as well for yourself. And this might be the start of a partial fraction question. So you could do the same steps. Notice A, for example, is clearly 2. Or if you wanted to, you could, for this one, you could even jump straight into an answer for a partial fraction. Now notice that x squared plus 3x plus 2 is the same as x plus 1, x plus 2. So what you could do instead of trying to make it this format here, you could match it up with ax plus b plus some number. This would be a different c, okay? It's a different c to what's in the question. So maybe I'll use an e instead, to some number over x plus 1, and then let's do a different one again, to some number x plus 2. And if you jump in and you match everything up, okay, so what do I mean by jump in and match everything up? I mean, if you multiply this by an x plus 1 and an x plus 2, and the same here, and an x plus 2, an x plus 2, an x plus 1, an x plus 1, you can sort of jump straight to comparing coefficients to turn things into their quotient and partial fractions all in one step. Okay, so there we go, comparing coefficients with long division.